We're now going to go through a proof that is asking whether or not the information listed in the statement is enough to prove that this image is a parallelogram. So I'm going to keep our notes about what makes something a parallelogram right next to me so that it's easier for me to analyze if this is sufficient or insufficient information. So let's read our first statement. A is congruent to C. Well, we do know that opposite angles are congruent. This is only one pair of opposite angles, though. These two angles being congruent doesn't necessarily mean that these two angles are congruent. For example, if you look at the image of a kite, these two angles are congruent to each other, the opposite angles, but the other two are not. So this image could just be a kite. So proving that these two angles are congruent is not enough to prove that the entire figure or quadrilateral is a parallelogram. We'd also need to know that B is congruent to D. So this is insufficient. AB is parallel to CD, and AD and BC are parallel. So they just proved that both sides are parallel. Both pairs of opposite sides are parallel. Well, we know that a quadrilateral is a four-sided figure in which both pairs of opposite sides are parallel. So this is enough to prove that it's a parallelogram. If we know that this is parallel to this and this side is parallel to this side, there's no way that it could be anything else. It couldn't be a quadrilateral. It couldn't be a kite. It couldn't be a trapezoid. It could be a parallelogram, which could be a rhombus, a rectangle, or a square. All of these have parallel sides, but they also all are parallelograms. So this is definitely sufficient information to prove it's a parallelogram. Our third statement is saying that opposite sides are congruent. This is also sufficient information to prove that it's at least a parallelogram. Again, four sides being congruent means that it could not be a quadrilateral or just a kite, just a trapezoid. It would be a parallelogram. It could be a rhombus, a rectangle, or a square, but again, these all fall underneath the umbrella of parallelogram. AB is parallel to CD, so this side is parallel to this side, and this side is congruent to this side. So this statement is just telling us that one pair of sides are parallel, and one pair of sides are congruent. We need to know that both pairs are parallel, and all sides of opposite sides are congruent. Just knowing this and this is not enough information to prove that the entire thing is a parallelogram. So that's insufficient information. The diagonal joining vertices A to C, so that would be the diagonal, is congruent to AD. So this diagonal is congruent to this side. Nothing here states that diagonals and sides should be congruent. So this is definitely insufficient information. The diagonal joining vertices, please change these, A and C, which is the line I just drew, and the diagonal joining B and D bisect each other. Well, this is the last statement. Diagonals bisect each other. If the diagonals bisect each other, then it definitely has to be a parallelogram. So that would be sufficient information to prove that this is a parallelogram. In our next prompt, we read, Zulema constructs a parallelogram, ABCD, below. The diagonals intersect at point O. She wants to prove that the parallelogram is a rectangle. Which of the following results is sufficient for her to prove that parallelogram ABCD is a rectangle? So we're going to keep our criteria for our rectangle right next to us as we go through this. Triangle ADB, ADB is congruent to triangle DBC. Let me use a different color. So this is saying that if we were to look at this rectangle instead as two triangles next to each other, that they're congruent. So let's think about this. If these triangles are congruent, we know that it means all three sides are the same length and all of the angles are also the same. So we could say that this side is congruent to this side is congruent to this side, and all of the angles are also congruent. So this angle is congruent to this angle, this one to this one, and this one to this one. This seems like a pretty enticing option because it proves that all four sides, or the both pairs of sides, are congruent, and all four angles have to be the same. We know that a rectangle is a parallelogram with four congruent angles, right? In a parallelogram, we know that opposite angles are congruent, right? But we talked about this. These could be congruent, but not necessarily congruent to the other pair. In a rectangle, all four have to be the same. So in this case, if this angle and this angle are congruent, and this are congruent, we know that this whole thing is congruent to this, and therefore has to be congruent to these as well. So this could be an answer, but let's take a look at some other options. The next one is saying triangle DOE. DOE. That should say, I'm sorry, DOC. And that should say AOB. Change that. So that's saying these two are congruent to each other. Well, that takes care of one half of this, right? We know that this triangle is congruent to this triangle. That's great. But what do we know about the other two triangles that are being created? Are the sides congruent? Are they parallel? This also says that these are congruent, which means we know that the angles are the same and the lengths are the same, but do we know that everything else is the same? This doesn't seem like as much information, so we're going to cross that out. C says DC is parallel to AB, okay, good, and DA is parallel to CB. Okay, so it's saying this side is parallel to this side and this side is parallel to this side. Well, that means that this is definitely a parallelogram, but that's not enough information to prove that it's a rectangle. It could just be a parallelogram, but all of the angles are different. So that is not enough information. DO is congruent to OB, so it's saying this line segment is congruent to this line segment, and this is congruent to this. So basically that these two bisect each other. Well, we know that in a parallelogram and a rectangle that the diagonals bisect each other, which is what this is saying. But we also know that the diagonals have to be congruent if it's a rectangle. This just tells me that this is congruent to this and this is congruent to this. It's not telling me that the entire lengths are congruent to each other, and that's the difference in making it a rectangle. So this is also not enough information. Therefore, we're going to go with A as being our correct answer.